Hello everyone, in this video let me discuss about Z transform related problem number 3. Find the Z transform and ROC of the following: x of n equal to a power n u of n minus b power n u of minus n minus 1. This is very important problem. Write the solution. Write the given data. What are the values are given? X of n equal to a power n u of n minus b power n u of minus n minus 1. Let's write the Z transform formula. Z transform Z of x of n equal to x of z equal to summation n equal to minus infinity to infinity x of n into z power minus n. Next is substitute x of n. So x of the previous step can be replaced by x of z equal to summation n equal to minus infinity to infinity a power n u of n minus b power n u of minus n minus 1 into z power minus n. See here, this u of n and this u of minus n and minus 1 only used for the limit application, okay? Only used for this one and this one, okay? Only used for limit, okay? Next step, x of z equal to n equal to 0 to infinity. How means, we know for the unit function the limit range. See, in the side you have write u of minus n minus 1, right? In the previous problem line, for the this is for negative side, 1 for n less than or equal to minus 1, okay, and 0 for n greater than 0. This is a condition for u of minus n minus 1, okay? There is nothing. See here, minus n minus 1 equal to 0 and minus n equal to 1. Then n equal to minus 1 to infinity. That is negative range. This is a negative range. You are right. So, understanding purpose. Okay, here. Okay, next. Okay, next. Substitute the limit n equal to 0 to infinity a power n z power minus n. Next, minus, you have to split that term, okay, because in between minus sign, no. So you have to split the term, single term into two term. So that is first term minus second term, likewise, okay. Summation here also, see the limit for the second term. For the first term, we know u of n equal to, for the lower limit 0, upper limit 1. The limit, there is u of n range vary from 0 to infinity. So 0 to infinity here. For the second term here, minus n to minus 1, no. So here lower limit n equal to minus infinity to infinity can be replaced by minus infinity to minus 1. Minus b power n into z power minus n. For the next step, summation n equal to 0 to infinity, take the power term, n is, take it as outside, that's common, okay, a into z power, see here minus n, right? So a into z power minus 1, the whole power n, minus summation n equal to 1 to infinity. There is, in the previous problem I already explained, once the limit change to be positive means, how means, here I will explain here. See here, this is a limit range timeline, plus infinity, minus infinity, this is for 0, this is for 1, this is for minus 1. Now here, minus infinity to minus 1. So minus infinity to minus 1 can be replaced by 1 to infinity. That is, negative region can be changed by positive region. So in the limit change means automatically inner term power also sign change, okay? So automatically inner term power also sign change. So b power minus 1 and z power 1, okay, the whole power n, because here b power plus n, z power minus n. Here the limit, here the power sign also change because of the limit change. Okay, so b power minus 1 z power plus 1 the whole power n. Okay, next apply the formula. If you have any doubt, just refer the previous problem. I will attach in video end of this video. Okay, apply the z transform formula. Z transform formula. X of z equal to 1 by, for the first term, summation n equal to 0 to infinity, take it as keep it, this is for a. Okay, summation n equal to 0 to infinity a power n formula 1 by 1 minus a. Here instead of a you got right a into z power minus 1. So 1 by 1 minus a into z inverse plus, see here 1 to infinity, right? While n equal to 0 to infinity we have the formula, this is the formula for the n equal to 0 to infinity, but here the limit 1 to infinity, this limit can be changed into 0 to infinity. Okay, once the limit changed from 0 to infinity means, see here, that's nothing, minus infinity to minus 1 and 0, this is for plus 1, this is a positive, no. So here this limit can be replaced by 0 to infinity. Okay, once 0 to infinity means in between they having 0 to 1 range. So what we have to do means 1 minus the summation n equal to 0 to infinity is the correct form for the previous step. Okay, summation n equal to 0 to infinity and a into z power minus 1 the whole power n minus, here right 1 minus, see here minus term, here also minus term, no, right, take minus term as outside, so minus of minus plus here. Okay, so 1 minus summation n equal to 0 to infinity b power minus 1 z to the whole power n. Now apply the limit, you have to write the term to here. Now apply the limit. Okay, apply the formula. X of z equal to 1 by 1 minus a, no, so 1 by 1 minus a into z inverse, it's the first term. The second term 1 minus, here also apply the limit, 1 by 1 minus b inverse into. So next step, take LCM for the second term, 1 by 1 minus a into z inverse plus b, here right, 1 minus b inverse z minus 1, the whole divided by 1 minus b inverse into z. So the plus 1 and minus 1 get cancelled. Okay, both are get cancelled. The remaining term 1 by 1 minus a into z inverse plus z by 1 minus b inverse into z, right? Next here b inverse minus b inverse into z. Okay, for the second term, here a into z inverse plus, here the second term, take for the denominator take minus b into z, minus b inverse, take it as outside, so z minus b. For the next step, this b inverse minus b inverse and denominator minus b inverse get cancelled. The remaining term here right in term of z by z minus c plus z by z minus b. Here nothing, multiply numerator and denominator by z. Then get the step as x equal to x of z equal to z by z minus a plus z by z minus b. This is for x of z. Next find ROC, right? Here write ROC. It's very easy step. Refer this line. This is the exact line for to find the ROC, right? See here 1 minus the term. Here also 1 minus the term. Take the 1 minus the term, modulus a into z inverse less than 1. Okay. Likewise for the second term, modulus b inverse z less than 1. Right. See here this for the second term minus, sorry, b inverse z. Here a into z inverse. So write the remaining steps, a divided by modulus z less than 1. So A less than modulus Z. Always modulus of Z term keep it as left side. So modulus of Z, the arrow, the range, the direction to be in, the that is focus on modulus of Z. No, so greater than A. This is for first R. That is first one ROC. Likewise, write the second term ROC EZ divided by B less than 1. So EZ, modulus of Z less than B. Okay. This is for the second term ROC. Next, compare these two. Compare these two ROC limit. So in general, here there is minimum range in the, that is for A, right? So A less than modulus of Z less than B. This is the ROC range for the given problem. Okay. Then draw the ROC diagram, ROC plot. Here two pole is there. This also poles, right? This one of the pole. This also, there are two poles is there. So you have to draw two circle. One circle surrounding another one circle. Okay. Okay. So here one of the, there is ray A. This is for one pole. This is for another one pole. So here this is the limit. This is the range for imaginary of Z. Here real of Z, right? Okay. Then shaded area based on the EZ format. Okay. So EZ region. So EZ regions are less than, that is A less than modulus of Z, and B less than A less than modulus of Z less than B. There is nothing. EZ region in between A and B. This is a concept. So in between, this is a region for, okay, ROs. Okay. Surrounding area, that's nothing, EZ plane. This is for EZ plane. This is for ROC, region of convergence. Okay. Then write the final step. X of Z equal to Z by Z minus A plus Z by Z minus B. That's nothing. ROC of A less than modulus of Z less than B. That's all about this problem.